Hello, assalamu alaikum. Welcome to my channel. Today I am going to discuss about momentum. Momentum. What is momentum? Momentum is the product of mass and velocity. So momentum is the product of mass and velocity. That means momentum equal to mass into velocity. Momentum is denoted by P. P equals to m into V. M into V. Momentum equals to mass into velocity. So this is the formula, main formula. Momentum. Remember, unit of momentum is kg meter per second. Why kg meter per second is the unit of momentum? Because unit of mass is kg and unit of velocity is meter per second. So kg meter per second. Momentum is a vector quantity because it has both magnitude and direction. So remember another important thing, if one vector quantity is multiplied with another scalar quantity, then result always vector. So here velocity is a vector quantity because velocity is the rate of change of displacement. So that's why velocity is a vector quantity. That's why momentum also vector quantity, because the product of mass and velocity is called momentum. So remember, momentum is a vector quantity. So momentum is a vector quantity. Vector quantity because it has both magnitude and direction. The direction of the momentum is same as the direction of the velocity. Why momentum is important in physics? Because momentum, according to the Newton's second law of motion, according to the Newton's second law of motion, remember, force is directly proportional to rate of change of momentum. Force is directly proportional to rate of change of momentum. So force is directly proportional to rate of change of momentum. So we can write force. There is a formula, F equal to mass into acceleration. Again we know acceleration equal to final velocity minus initial velocity divided by time. So after multiplication we get mv minus mu divided by t. So force equal to change in momentum divided by time taken. So force is equal to change in momentum divided by time taken. Force is directly proportional to force equal to change in momentum divided by time taken. Unit of force is Newton. Unit of change in momentum delta P divided by T. So change in momentum kg meter per second. There is another second. So kg meter per second square equal to force. Now impulse. If a large amount force acts for a very short time, then the product of force and time is called impulse. So if a large amount force acts for a very short time, so when any car crash or any accident occurs, when a collision between cricket bat and ball occurs, then a very large amount force acts very short time, then the product of force and time is called impulse. So remember, if a very large amount force acts for a very short time, for a very short time, then the product of force and time, then the product of force and time is called impulse. It's called impulse. So if a very large amount force acts for a very short time, so impulse equal to force into time. Impulse equal to force into time. But remember, force into time equal to change in momentum, mv minus mu. So we can calculate impulse force into time, or mv final momentum minus initial momentum. So now conservation law of momentum. When any collision occurs between two objects, then, or any explosion occurs, then remember, without any external force except collision or explosion, total momentum before collision or explosion is equal to the total momentum after collision or explosion. So this is the conservation law of momentum. Conserve means constant, remains constant. Conservation law of momentum. According to the conservation law of momentum, without any external force, except collision or explosion, except collision or explosion, total momentum before collision, collision or explosion equal to total momentum after collision or explosion. So total momentum before collision is equal to total momentum after collision. So total momentum before. So total momentum before collision is equal to total momentum after collision. After collision. What is the meaning of this? So when any collision or explosion occurs, then remember momentum remains conserved. Conserved means constant. That means remains same. So in any type collision or explosion, total momentum before is equal to total momentum after. Total momentum after. What is the meaning of this? Say there is an object. Say there is an object A. Mass of the object is ma, and initial velocity of the object is ua. U is the initial velocity. So another object moves in the same direction. So with a greater velocity ub, this object is this object is b, and mass is mb. So before collision, remember before collision. So here ub is greater than ua. That means the speed, initial speed of ub is greater than ua. So b object collide with a object. So after collision, the velocity of the a object increases. So final velocity of the a object is va, and in final velocity of the object b becomes smaller. So this one is the b, and mass of the a object ma, mass of the b object mb. So this one is the after collision. After collision. According to the conservation law of momentum, total momentum before. So total momentum before. So momentum for a object, m mass of the a object, and initial velocity of the a object ua, plus mass of the b object, initial velocity of the b object. And here final velocity, final momentum of the a object ma va plus mb vb. So according to the conservation of law of momentum, these two must be equal. So according to the conservation law of momentum, for this case, because after collision the two object moves combinedly. So that's why after collision two objects move separately. That's why we use MAVA plus MBVB. So this one for one condition. Now we discuss about another situation. Here two object A and object B. Mass of the object A is MA and mass of the object B is MB, and initial velocity of the object is UA and initial velocity of the object UB before collision. So after collision they stick together or join together and they move combinedly after collision. So in this case total momentum must be zero. So MA into UA plus MB into UB equal to, here two objects combined together, that's why combined mass is MA plus MB. Here combined velocity after collision is V. That's why this one will be the formula for combined velocity. So remember, so here total momentum before collision is equal to the total momentum after collision. But remember here the mass they move combinedly, join together. That's why we use ma plus mb into v. Okay, now we try this. We want to try this. Solve this. We want to solve this question. Look at the question. Question number 1. A track of mass 0.5 kg moving at 1.2 meter per second collides and remains attached to another initially stationary track of mass 1.5 kg. Calculate the common velocity of the track after the collision. Calculate the common velocity after collision. So remember the common velocity. Let the common velocity after collision. Let the common velocity. The common velocity after collision. Velocity of the trucks after collision b is the common velocity. So according to the conservation law of momentum total initial mass of the A truck, initial velocity of the A truck plus mass of the B truck, initial velocity of the B truck equal to total ma plus mb into v, common velocity. So 0.5 into 1.2 plus 1.5 into 0 equal to 0.5 into plus 1.5 into v. So 0.5 into 1.2, 0.6 kg meter per second, and here before collision momentum of the B is 0. So 2 into v. So v equal to 0.3 meter per second. So after collision, two trucks combinedly move in the right direction with a velocity 0.3 meter per second. 0.3 meter per second.